Welcome. In this video I will show how easy it is to set up the fluidOps Scaleout cluster. To get started, I have a copy of the latest 7.0 information workbench, which I will simply unzip. And I will have a cluster setup which has two backend nodes forming a cluster and one client which connects to the cluster via a load balancer. So consequently, I will copy this another 2 times. So we have 3 instances. Let me use this one as the server, second one is the second server, and the third one is going to be the client. Okay, next up, I will have to configure the 3 nodes. So let's first have a look at the client config. So it's a simple standard config file for the information workbench. The first line defines the repository using this fluidOps repository factory, which points to the Scaleout backend. I have username and password for the client to connect to the cluster, and I have the option that the Scaleout cluster is enabled. The address of the cluster to connect to defaults to localhost on a given port range, which we'll see in a second in the setup page. Okay, let's switch to the server 1. Server 1, first of all, since I'm running localhost, I need to configure a different backend service port and also a different HTTP and HTTPS port. The same is true for the second cluster setup, which uses just an incrementing number here. So this is basically a demo setup that's only required if you run the cluster nodes on the same host. Secondly, there's a cluster redo location. So this is a shared folder. So all of the cluster nodes need to have access to this folder. This is the place where the redo logs are stored to allow a node to rejoin or join the cluster for the first time, and to make sure that all the transactions are replayed on that cluster node. Third option again turns on the cluster, and the fourth and fifth option are again username and password to allow inter-cluster communication. Again, the second setup uses the exact same values. Okay, so far so good. So what I need to do is I need to rename this to config prop, copy this into S1, move and replace, and same here. Move and replace again, and the client goes in here. Okay. So now let's start up the cluster. This is cluster node 1, cluster node 2. And to look at the cluster in action, we can now use the diagnostic tool. To start this tool, go to any one of the cluster nodes and navigate to the tools directory. And there is the diag tool. So this is sort of a system level tool which allows you to inspect system configurations, and one of them is the cluster setup. So this diag tool immediately opens up the S1 instance via the shared file system, and we have the cluster monitor and the cluster overview, which we can look at. So the cluster overview shows us what the current cluster looks like. So we have 2 nodes. It also shows the amount of CPUs and RAM for the clusters, the RMI address, as well as which one of the 2 nodes is the replica. So in this case, this is node 0 at the moment, and the master is node 1. Okay, and the cluster monitor shows us some CPU and memory charts. So let's minimize this for a second, and let's go to the client. third process is started, and we will use the browser. Okay, let me allow the access here, and we use the browser to connect to the GUI. Okay, here we go. So let's log in. And we can inspect the Scaleout help page, which contains a link to the client setup. So in this case, this is the page where you can change a running system, and you have all the relevant config settings on here on this page. You can also see that the cluster nodes have a certain default. That's why we didn't set it up in the config files a second ago. Okay, using a second browser, we will now look at one of the cluster nodes directly. So this is port 50,4400. So we're now connecting directly to the cluster. Again, let's log in. And we again go to this wiki page, and we'll have a look at the backend cluster node configuration. And again, here you see the settings we had earlier in the config files. Important thing here is that you can see this local redos, and that's actually something we can see here. So this is a folder which was created, which contains the quorum disk, the cluster ID, the cluster state, and the redo logs for the nodes. Okay, let's go back to the client. The client is again using the load balancer connected to, in a round-robin fashion, to the least busy nodes on the back end. And can now maybe just enter some data here. Let's just add a label. Okay, we're going to save that change. And now let's simulate a cluster failover. So let me kill any one of those server processes. So just shutting down this one. And I can go back to the diagnostic tool. And you can immediately see that node 1 has been killed. Node 1 was the master earlier, and node 0 is now elected itself to be the master. Okay, now we'll go ahead and add a second statement. Okay, we save this. This is saved to the database. And now we'll do the following. We will restart node 1. Check the cluster setup to make sure that the node has entered the cluster, and it will then replay the redo log and pick up the statement that we just added. Okay, here we go. So the cluster is complete again, and I will now use this, shut down the second one. Okay, let's check the cluster overview, make sure it disappears, and then we will check the browser, make sure that the statement is still there. Okay, now the node is gone. Okay, we're refreshing the page to make sure that the client has a chance to connect to the changed backend node, and we have a look, and of course here's our second statement. Again, this statement has been entered into the first cluster node, which was subsequently killed. But before it got killed, the second cluster node rejoined the cluster and picked up the transaction redo log. And then a shutdown or killing the first node, it didn't really affect the cluster.